Hi guys, this video is going to guide you through the post-lab questions, and at this point you should have watched the lab procedure video and accessed the lab data. Remember, you're not using the data that was shown to you in the lab procedure video. I've actually uploaded data that was collected, and you can add that to the data table that is in your lab handout. So just wanted to kind of make sure that you're accessing the correct lab data. So the first thing that is asked of you in the post-lab calculations and analysis is to construct a results table. So they gave you a table in the lab handout for you to put all of your data that was collected, and now it's up to you to make your own data table to summarize all the results of your calculations. So there's 6 things that need to be included in that data table, and so they're all listed here. I'm just going to highlight them for you so you make sure when you make your data table that you are including these things. Now you also want to make sure that you're calculating these things to enter into that data table, and you know that you need to show me at least one calculation for each of the 6 things here. You're going to have to do the math for all of them, but you need to show me the math for at least one of those calculations. So the first thing, well, let me just say this too. You want to make a table that's going to show each reaction, so reaction A and reaction B with magnesium and then with magnesium oxide, and for each trial. So you're going to have columns for trial 1 and trial 2 for the magnesium, and trial 1 and trial 2 for the magnesium oxide, and then you're also going to have rows for the 6 things that are listed in this or on this sheet here that's on this slide. So you're going to calculate the mass of the hydrochloric acid solution, and you are going to calculate the total mass of the reactants. So that's saying make sure that you include the solid and the liquids. So that means total mass means you're using the magnesium or magnesium oxide and you're adding it to the mass of the hydrochloric acid. So calculating the mass of the hydrochloric acid, remember you're going to use density to do that. If you have questions about that, let me know, but that's something that we have done before. And then the third thing that you're going to want to include is that change in temperature, so delta T. So you'll take final minus initial and put that into the data table. And then the next thing is the Q value, so the heat that's absorbed by the solution, and it tells you exactly what to do here. It gives you the specific heat. We're going to use the same as water, and it's telling you to use the total mass of reactants from number 2 as your mass, and delta T you calculated in 3. So you're going to be able to plug in all of that information and calculate Q for each trial, and then you'll put that in your data table. And then number 5 is number of moles, and I will go over how to calculate that. And number 6 is enthalpy change, and I will go over how to calculate that as well. So let's take a look at number 5. I'd like to focus on number 5 for right now. It's asking you to calculate the number of moles of magnesium and magnesium oxide. So just a couple hints here with this one. You have the grams of magnesium, and you also have the grams of magnesium oxide. So we're just going to do a simple conversion here to go from grams to moles. And if you remember from anything that we've done in this class, when we are converting from grams to moles, we are going to use molar mass. So you're going to have to look up the molar mass of magnesium and calculate the molar mass of magnesium oxide, and you're going to do that simple conversion to get your moles of magnesium and magnesium oxide. So that's what it's asking you in number 5. I hope that was helpful. If you still have questions, reach out and ask me. You can ask me on the forum. You can also ask me via email, and I'll be happy to help you with that. Now I want to take a look at number 6. Number 6 is asking you to calculate the enthalpy change. And enthalpy change is delta H. So here we're calculating delta H. You're going to need the information that you calculated in number 4. That information in number 4, you are calculating Q, and Q, the units are in joules. So Q is in joules. So in number 6, we want delta H in kilojoules per mole. So you've calculated the moles in number 5. In number 4, you've calculated joules. So we're going to take the information from number 4 and the information from number 5 to calculate delta H. So what you're going to need to do is convert your answer in number 4 to kilojoules. So you're going to do a conversion there. And then you're going to divide that by the moles that you calculated in number 5, and you're going to get a value for delta H. So that's what you're going to do in number 6, and then you're going to put that in your data table. Okay, so that would be the enthalpy change that you would calculate for number 6. So if you have questions on that, just send me an email again or ask in the forum. I'll be happy to help with that. But again, you're just basically doing a quick conversion of number 4 from joules to kilojoules and then dividing by the number of moles you calculated in number 5. You're doing that for each trial and then plugging that into your data table. I think number 7 here is pretty self-explanatory. They're asking you to calculate the average enthalpy change for reactions A and reaction B. So you want to take the 2 trials from reaction A and calculate an average delta H, and you want to do the same thing for reaction B. Just a note that they have there is the enthalpy change is positive for an endothermic reaction and negative for exothermic. So it's up to you to determine, based on your data, if these were endo or exothermic reactions, and make sure that your delta H is showing that with the sign either being positive or negative. So don't forget to double check that when you're calculating your delta H. So moving on to number 8. Okay, for number 8, you want to take a look at your answer to pre-lab number 2, which I have written out here, where you're adding together the delta H's of reaction. So what you're going to do here is A and B are what you calculated in number 7, those averages for reaction A and reaction B, so you'll plug those in. Again, you want to make sure that if you have a negative value or a positive value, that you're putting those signs in. The other thing that you want to make sure of is if you reversed any of these reactions when you looked at them in the pre-lab, you want to make sure that you're plugging in correct values for those things here. So you want to definitely go back and double check what your answers were in pre-lab. You also want to make sure that you're taking your pre-lab answer from question pre-lab number 3 for the delta H of C, because that you calculated using thermodynamic data. So this is from number 3 in the pre-lab. So that's where you're going to get those values. Now, in order to calculate that overall reaction, you have to look at the equations, and you had to manipulate those equations, and that was part of the pre-lab question. So you're going to need to kind of focus back on those to determine this delta H. I don't want to give you too much information because I want you to try to use what knowledge you have of Hess's law and the calculations that we did back in that thermodynamics unit, to kind of focus those thoughts on how to calculate your delta H of reaction here. So I'm going to leave that for you to think about. But again, if you have questions, please make sure that you ask me, and I will help you if you have questions on number 8. So that's my little bit of hints for number 8. So number 9, we are going to take the heat of reaction for equation 1, which is what you solved for in number 8, and you're actually going to now compare it to the heat of formation of solid magnesium oxide. So that reaction for solid magnesium oxide, whoops, I didn't mean to do that. Okay, sorry about that. So you're going to look up the heats of formation from the chemical reference table that is on the class page that you've been using for all of these thermodynamic math problems, and you're going to calculate the delta H of reaction by doing summation. So you're going to look at the products minus the summation of the delta H of the reactants and calculate the delta H of the magnesium oxide reaction. So that's going to be, this will be your theoretical. So that's what it's asking you to do in part A. And then part B is calculating percent error. So if you remember what the percent error calculation is, and we haven't used this in a while, so I'm going to give you that equation to help you out here. You're going to take the theoretical, so that's what you just calculated in part A. You're going to subtract it from your experimental value that you calculated in number 8, and then divide it by that theoretical value multiplied by 100, and that will give you the percent error. So this is going to tell you how close or how far off you were from the theoretical value that you should get for the formation of magnesium oxide, and you're going to compare it to what your experimental data showed you. So this will kind of give you an indication of how well you did your experiment. What was your percent error? And so that is how you will then be able to determine if you were successful or not when you write up your conclusion. So make sure that you follow the lab report guidelines when you start to write up this lab report. There's lots of hints and explanations in there on how this should be written up. Again, if you have any questions at all, please reach out to me. I'll be glad to help you out. If you want me to take a look at any of your math, you can send me a screenshot of or a picture of your math that you've worked out, and I can kind of guide you and give you some hints if there are any mistakes in there. So that's it for the post-lab analysis questions and setting up that second data table. And now you're just going to write up your lab report. And that's going to be due on Friday. Hope you guys are well. And again, ask questions if you need. Take care.